You see it moving a little bit? So that's it cannot go in there because if I drop it, it's gonna fall apart, right? So it has to be sturdy, it has to stay in the same exact position that you drop, okay? But you're almost there.
Camera's
This is
running.
almost perfect. You guys are almost there. Okay. You ready? Okay. This needs to be like this. Okay. Like this needs to be the top of the head, right? Like this. You can make this longer. And then the thing is that this part needs to be a little bit off the ground, and here you have to have this part. Okay?
Did you all have a good time doing something different?
Woo!
You enjoyed it?
Do you have a photo?
Looks like I see some good artwork. Okay? So it looks like you all were having fun, and we hope that you were. Because we're getting ready to go further and further into what we just did. These are elementary steps. So, wow. He went way far. Okay? Okay. Let's give him a hand. Looks like he, okay. Let's give a hand over here too because look like that's pretty impressive. Another hand. All right. Without any further ado, I want to introduce a young man to you all that's responsible for the fun that you just had. This young man comes to us from NASA, and his name is Ben Kessler, and he graduated from a university called Tufts University. Anybody ever heard of that? So without any further ado, I want to introduce to you Mr. Ben Kessler. Give him a hand.
Hello everyone, I'm Ben. So you guys have heard of Tufts? Do you know where that is?
No.
Any idea? Okay. So that's in Boston. That's where I came from. And I worked on a program there where we went into classrooms and taught engineering, science, and math. And what we did was we took that program and we came and adapted it to NASA and then brought it to you guys. So I went ahead, went to NASA from Tufts, created some lessons, got to see a whole bunch of cool stuff, and then put it in lesson form and brought it to you guys. So one of those things was I went to this bed rest facility. You guys all know what the bed rest facility was? You all learned about that today? Yeah? So you can tell me what an analog is. An analog is what they use to do tests that they can't otherwise do in space so that they can learn what they need to know when they go to space. So one of those things is a bed. So who has a bed they want to show?
Show your beds up.
Go ahead.
Very good job. Show
So
your
you got a
bed.
roll
Yeah.
bed?
Okay. Put it there.
Good. The rolls. So does mine. I made one for you guys. Show you what I did. Mine's got a little handle so you can push it around and you can adjust it up and down. You guys got a handle? You guys did a great job. Okay, so this was the first step in your robotics, right? But next month and the month after that, you'll be doing some more stuff with this and it'll be getting a little more complex. So I'm gonna show you guys what you might be able to accomplish as you continue going on with the program. So, I have this one. This would be an exercise device that could be used in space or on the moon. So who can tell me one thing that's different about space than here? No gravity, right. So in space, things aren't quite so heavy because there's no gravity pulling it down. So what you can do is instead of using the weights to make you stronger, because you're not going to be lifting them up, you're not going to have any weight to them, you can actually create the weight using something else. I did it using this motor. So if you watch, it'll push down, and when you push up, it'll push back down on you. If you guys want to pass it around and kind of play with it a little bit, you can. But you can see how, let everyone have a chance, you can see how that if there was no gravity, you'd still be able to push against something because the weight of the bar would be created by the motor. Does that make sense for people? Yes, no? Can you not pretend that you understand at least?
Janelle.
What's up? Good. You guys can pass that around. Okay. So one other thing I got for you. I'll let you off to lunch after this. Is when people are in space, you know, there's a space station going around the Earth, right?
Yes, sir.
You know how many people live up there?
12.
0.
Half that. 6. There are 6 people up there. What happens is it's going around the Earth really, really fast. So you see the sun come up, the sun goes down, sun comes up, sun goes down. Not like here where once a day it happens. It happens 16 times a day. So they need a different way of setting their alarm system. So I made them a little alarm that works by seeing different types of sunrises. You good? It's okay. You guys can just you don't have to press the buttons. It's all good. Just leave it alone. It's okay. You can just pass around the whole thing. You get to play with it. You guys will get to do something like this next week or next month. Anyway, so what I did was I created an alarm for astronauts to use so that when the sun is rising, that they can wake up with the sun. And that's important because the sun helps you wake up. If you wake up in the middle of the night, you'll still be tired. So, you guys all right? Okay. So what happens is, I have a light sensor here, right? Can everyone see that? This is taking in, it's reading the light around here, right? And it senses that there's light here. Now if I close it, it's kind of like the sun has gone down, and the sun rises again, and the sun goes down again, and the sun rises again, and it goes down. And eventually, if you can see enough light, you gotta point it up there. It should start talking. Hold on. Okay. So this would be pretty annoying as an alarm, right? Can you all hear it? So now, say you want to go to sleep, you want to try to go back to sleep, it'll run away from you.